So, hope you people have gone through the syllabus of net physical sciences that I have uploaded before. So, the part B. In that, the first chapter is mathematical methods of physics, and in that, the first topic is dimensional analysis. So, the definition of dimensional analysis is it is a conceptual tool to understand physical situations involving a mix of different kinds of physical quantities. In dimensional analysis, we analyze the formulae of every physical quantity and try to explain it in mainly three fundamental units such as length, mass, and time. So you will understand this definition by seeing the next table that I have uploaded. So this is the table containing some physical quantities and its dimensional formulae. L, M, and N are some of the fundamental units or physical quantities which have the dimensional formula L, capital M, and capital T. Now, the dimensional formula for velocity is L t raised to minus 1. Why it is L t raised to minus 1? Because the formula of velocity is distance traveled by time taken. The distance is measured in length, that is L, and divided by time taken, that is T, divided by T, that is L divided by T, that is equal to L t raised to minus 1. So this is the dimensional formula for velocity. So the dimensional formulae for all these physical quantities are derived like this. So you people should by heart all these dimensional formulas of these physical quantities to solve the problems that asked in the physical science examinations of NET. So this is the question on the dimensional analysis which is asked in December 2015. So in the scattering of some elementary particles, the scattering cross section sigma is found to depend on the total energy E and the fundamental constants h, that is Planck's constant, and c, that is the speed of light in vacuum. Using dimensional analysis, the dependence of sigma on these quantities is given by, so the options are given, you have to choose the correct option. So solution: given the sigma, that is proportional to E, and sigma is proportional to h, and sigma is proportional to c, that is which is dependent on E, h, and c. That is, we can write it as sigma is proportional to E raised to alpha, h raised to beta, c raised to gamma. Alpha, beta, gamma are the constants. So let's take this as equation 1. We know that the dimension of sigma is equal to L raised to 2. The dimension of E is equal to m L square t raised to minus 2. The dimension of h is equal to m L raised to 2 t raised to minus 1. The dimension of c is equal to L t raised to minus 1. So from equation 1 we can write it as sigma, that is L raised to whole square, that is proportional to, that is E raised to alpha, that is m L square t raised to minus 2 to the whole raised to alpha, and this is h raised to beta, and this is c raised to alpha. So we get L whole square proportional to m. So if we multiply all these we get m raised to alpha plus beta L raised to 2 alpha plus 2 beta plus gamma t raised to minus 2 alpha minus beta minus gamma. So comparing both the sides we get alpha plus beta is equal to 0 comma 2 alpha plus 2 beta plus gamma is equal to 2 because L on the both sides, comma minus 2 alpha minus beta minus gamma is equal to 0 because there is no t on the left hand side. So from 2 alpha plus 2 beta plus gamma is equal to 2, so taking 2 out, alpha there exists alpha plus beta plus gamma is equal to 2. So we know that alpha plus beta is equal to 0. Putting alpha plus beta is equal to 0, we get 2 into 0 is equal to 0, we get gamma is equal to 2. So let's take this as gamma is equal to 2. So from alpha plus beta is equal to 0, we get alpha is equal to minus beta. By putting gamma is equal to 2 and alpha is equal to minus beta in minus 2 alpha minus beta minus gamma is equal to 0 equation, we get minus 2 into minus beta minus 2 is equal to 0. That is plus 2 beta minus 2 is equal to 0. Beta minus 2 is equal to 0. We get beta is equal to 2. By putting beta is equal to 2 in alpha plus beta is equal to 0 equation, we get alpha is equal to minus 2. So we get alpha is equal to minus 2, beta is equal to 2 and gamma is equal to 0, 2. So from equation 1, sigma proportional to e raised to minus 2 h raised to 2 c raised to 2. So we get the correct option, that is sigma proportional to h raised to 2 c raised to 2 divided by e raised to 2, which is the correct option. This is the another question asked on dimensional analysis in June 2016. So using dimensional analysis, Planck defined a characteristic temperature Tp from powers of the gravitational constant G, Planck's constant h, Boltzmann constant kb, and the speed of light c in vacuum. The expression for Tp is proportional to, we know that the dimension of h is equal to m L raised to 2 t raised to minus 1. The dimension of kb is equal to m L raised to 2 t raised to minus 2 k raised to minus 1, which is the entropy. Dimension of g is equal to m raised to minus 1 L raised to cube t raised to minus 2. The dimension of c is equal to L t raised to minus 1, which is velocity. So the dimension of the square root of h into c raised to 5 divided by kb square into g, which is the option A given. So we have to put the dimensional formulas in this option to get the correct answer. So the square root of the h dimensional formula is m, which we have written here. C raised to 5, that is cl raised to 5 into t raised to minus 5, we have written here, divided by kb whole square, that is the whole square of kb, we have done this here. And g, we have taken the dimensional formula of g here. We, after the substitution, we get the square root of k square. We get Tp is equal to k, we get k, that is the dimension of the temperature. So the correct option is the given A option, which is this one. So we have to put the dimensional formulas in these options to get the correct answer.